Alright, so today's question is find all integers n such that n square plus 1 is divisible by n plus 1. Okay, so we are asked to find all integers n such that n square plus 1 is divisible by n plus 1, right? That means n square plus 1 by n plus 1 leaves no remainder. Okay, so now let's rewrite n square plus 1 in a different way. We will try to break n square plus 1 into something that contains n plus 1 so that we can uh, cancel out n plus 1 from both the sides. Okay, so n square, we know that n square minus 1 equals to n plus 1 n minus 1, right? So from here we can say that if we are trying to do this, suppose n square plus 1, we can also write it as n square minus 1 plus 2, right? And after that we will place the value of n plus n squared minus 1 with the value we have written on top over here. So it comes around to be n squared plus 1 equals to n plus 1 n minus 1 plus 2, right? So after substitution we are getting this thing. Now if we are dividing this whole thing, if we are dividing the whole n squared plus 1 divided by n plus 1, we will get n minus 1 n plus 1 plus 2 whole divided by n plus 1, right? So after that we are breaking from this addition into two terms. We will get n minus 1 n plus 1 divided by n plus 1 plus 2 divided by n plus 1. All right, so this part will become n minus 1 plus 2 divided by n plus 1, correct? So for this whole thing to be an integer, as we already know that n is an integer, right? As n is an integer, and for the expression n square plus 1 to be an integer, the RHS or right hand side, that is n minus 1 plus 2 by n plus 1 must be an integer. Therefore 2 by n plus 1 is also an integer. Therefore excuse me. We can say that n plus 1 must divide 2, right? So what are the integers that divide 2? Suppose, let's see what integers divide 2. It's either plus minus 1 or plus minus 2, either of the four, right? So we can also say that n plus 1 is equals to either one of the four, right? It is 1 minus 1, 2 minus 2. So what can be the answer from here? So we can say that n plus 1 equals to 1. So therefore, like, n equals to 0, n plus 1 equals to minus 1, therefore n equals to minus 2, n plus 1 equals to 2, therefore n equals to 1, n plus 1 equals to minus 2, therefore n equals to minus 3, correct? So the final answers are, therefore the values of n are 0, 1, minus 2 and then minus 3, right? So n equals to 0, 1, minus 2, minus 3. This is a very simple idea. The main core idea behind the problem is that we change the expression in a way so that most of it becomes divisible by n plus 1. That's our idea. There was only a small leftover part, that was 2 by n plus 1, right? And we have assumed that it's an integer, because if it's not an integer, then even it's not completely divisible by n plus 1, right? So to prove that, we have considered this to be an integer. So and from there we have also considered that if it's divisible by 2, therefore n plus 1 must divide 2. So according to that idea, we have found out that n can be either of the following values. Thank you.